working with normal distributions. So the empirical rule is only useful for evaluating specific values such as mu and plus sigma. Once the data set is standardized, however, any data can be evaluated. Okay, so the data is standardized by converting them to z values. Okay, also known as a z-score. Okay, so the z-value represents the number of standard deviations that a given data value is from the mean. Okay, that part is important. Okay, so the z-value represents the number of standard deviations that the data value is from the mean or the center of that graph that we were looking at yesterday. Therefore, z-values can be used to determine the position of any data value within a set of data.
I'm here. Here's my pass. Finish this one. Finish this one.
Which one is this?
14A.
11.4 C and A.
Yep.
11.5A.
Yeah. All right. So, quiet. The z-value for a data value x in any set of normal distributed data is given by z equals x minus mu over sigma, where mu is the mean. Okay? So mu is the mean. That's this one right here. And sigma is the standard deviation. Okay, so that's this part right here. Okay, so we can use that formula to find different pieces of our data. So in example 1, we want to find sigma if we're given x, mu, and z. Okay, so what we need to do is just plug in what we know into the formula here. So for z, we have 0.63. So I'll plug in 0.63 for z. That's equal to x, right? So we have x is 28.3 minus mu, which is the mean right here of 24.6, over sigma, which is what we're trying to find. Z is 0.63. Okay, so from here we just need to solve for sigma algebraically. So I'm going to multiply both sides by that sigma, okay, so that on the right they cancel out. So I have 0.63 sigma is equal to, and you can add or subtract those two terms right away. So 28.3 minus 24.6. That's 3.7. And then to get sigma by itself, what should I do? Divide both sides by 0.63. Okay, so your sigma is equal to 5.87. Okay, so if we were to look at our graph like we had yesterday, you know, that curve that we were working with. Okay, so here would be that curve we were working with yesterday, right? The center is your mean, Okay, our mean is 24.6. Right? Okay, so that's in the center. Okay, so that x value that they're talking about is 28.3. That's greater than 24.6, so that would be somewhere over here, right? That would be 28.3. Yep. Okay, so what your z-score does, it takes that 0.63 and multiplies by sigma, okay, to get how many standard deviations it is away from the mean. That x value is away from the mean. Okay, so that's what we were trying to do. So this is 0.63 standard deviation. Okay, so your z-score is how many standard deviations your x value is away from your mean. Okay, so I was given the z-score in this one. Okay, you already given z. So this one is a little bit easier to indicate the position of x in the distribution. Okay, so that's what this second part was asking for. Okay, indicate the position of x in the distribution. It's 0.63 standard deviations away from the mean. Okay, so that's what that z-score does. Okay, questions on that first one? How I solved? Anything like that? All right, example 2 then. This time we're finding x. Okay, and we're given the mean, the standard deviation, and the z-score. So again, we're just going to plug it into the formula from above. So since z is 0.73, start with 0.73. That's equal to x, which we don't know, that's what we're looking for, minus our mu value is 39 over the standard deviation, our sigma, which is 8.2. And again, I just have to solve for that missing value algebraically. So what should I do first to get x by itself? Multiply both sides by 8.2. Okay, so that they cancel out on the right here. So I end up with 5.986 is equal to x minus 39. Okay, then I'm just going to add 39 to both sides of my equation. Now, if you don't want to keep it as 3 decimals since it's really close to 45, you can just say x is about 45 instead. Okay, so if I have my curve again here, the middle one, right, is your mu value of 39. Now, our x value that we found was greater, okay? So that would be over to the right. So if we found our x value to be less than 39, we'd put it on that left-hand side, okay? Since it is greater, the space between them is how many standard deviations away. Okay, that's your z-score, so whatever z is, that's 0.73 standard deviations away. So that's what we would have to say for indicate the position of x in the distribution. So it is 0.73 standard deviations away from the mean. Okay, and you do need to state that. So sometimes you'll be given that z-score, so it's really easy to indicate that position of x, okay, because they already gave you the z-score. However, sometimes you'll have to solve for z, okay, and then you'll find that value, and you could say then how many it is away. Okay, questions? All right, so any combination of mean and standard deviation is possible for a normally distributed set of data. As a result, there are infinitely many normal probability distributions. This makes comparing two individual distributions difficult. Difficult distributions can be compared, however, once they are standardized using z-values. The standard normal distribution is a normal distribution with a mean of 0 and a standard deviation of 1. So our normal or standard normal, your mean is going to be 0, and it'll go up by 1 standard deviation or down by 1 standard deviation each time. And you can see we still have that normal curve with our probability percents there. Okay, it's just more standard using zeros and ones instead. So the total area under the curve is equal to 1, okay, or is 100%. Okay, so again, total area under the curve will be equal to 1. So your answers are going to be less than 1. Okay. Almost all of the data is between z is equal to -3 and z is equal to 3. So when we enter things into our calculator, we don't want anything less than -3 or greater than 3 as we enter our values. Okay, so it has to be between those. Your distribution is symmetric, okay, so it's the same on each side of that 0 value. And the mean is 0 and the standard deviation is 1. Okay, so we're going to use that normal curve to answer some questions on the back here. So the standard normal distribution allows us to assign actual areas to the intervals created by z-values. The area under the normal curve corresponds to the proportion of data values in an interval as well as the probability of a random data value falling within that interval. For example, the area between z equals 0 and z equals 1 is 0.34. Okay, so if you look at your curve on the front, area under the curve between 0 and 1 is 34%, so 0.34. Okay. Therefore, the probability of a z-value being on this interval is 34%. So we are going to use our graphing calculators next. So make sure you have those. Make sure they turn on and they're not out of batteries. So in example 3, the cholesterol levels for adult males for a specific racial group are normally distributed with a mean of 158.3. Okay, so I know the mean and a standard deviation of 6.6. Okay, I will need both the mean and standard deviation to do this. We want to find each probability. Then using the graphing calculator, sketch the corresponding area under the curve. So we want to find the probability that our x values are greater than 150. Okay, so first what I want to do is find the z-score. So I'm using z is equal to x minus the mean or mu over sigma or the standard deviation. So I need to find what z is. So I'm going to use 150 for x. Okay, so I'm going to plug in 150 for x. I know what the mean is. That's 158.3. And I know what the standard deviation is. That's 6.6. Okay, so to calculate the z-score, all we need to do is enter that into our calculator. So we have 150 minus 158.3. Okay, that's negative 8.3. Then divide that by 6.6. And I get negative 1.26 rounded. Okay, so it does end up with a stretched out decimal. I just rounded it to 0.26 there. Okay, so that's our z value. Since we are looking for values greater, okay, that means I need to go from negative 1.26 all the way to 3. However, if I look at this next part here, it'll tell me how to put this into my graph. Okay, so you can use a graphing calculator to display the area that corresponds to any z value by selecting second, and then distribution is what that stands for. Okay, that's the button that says vars. Okay, distribution is right above it. So, on my calculator, I would press second, and then distribution is right here, right above that vars button. Okay, then under the draw menu, okay, so go to the right, so you select draw, select shade norm, and then our lower and upper. So shade norm is right here. I'm going to press enter. My lower value is going to be the one that I found because I want the values greater than that. So I'm going to enter negative 1.26. Press your comma button. Okay, that's this one right here. Press your comma button. Okay, and then our upper bound is always going to be 3. So to 3. End your parenthesis. Now, before, what?
It says lower, upper, that NU thing.
Yeah, same.
Yeah.
Oh, lower, upper.
Yeah.
And then that side, yeah.
So, see, I
So
don't know how
you
to
don't have to
figure-
press the comma.
So now what? What are you taking here?
Just wait for it.
What?
Your lower is what we found, your upper is 3.
Here, let me see. Yes.
So your calculators might be a little different. Your lower, where it says lower, is negative 1.26. Your upper is 3. I do want you might have to redo this. I forgot. You need to change your window. Otherwise, you won't see your graph. Okay? So for my x-min, I'm going to do negative 4. For the max, I'm going to do positive 4, just so that we have that negative 3 and positive 3, right? Okay, then my scale I'm going to keep as 1. My y-min is going to be 0. Okay, and I'm going to go up to 0.5. Okay, and then my scale I'm not going to keep as 1 because then you won't see the whole graph. I'm going to put that as 0.125. Okay, so this is your window that you're using. Okay, then you can press second quit, and you should still, do you still have yours on your screen then? No? Then you might have to go back to second distribution. Okay, then enter your lower, negative 1.26, and enter your upper value of 3. And then press enter, and it should graph it for you. Or go down to graph or draw. So make sure you can enter all of that.
Yeah.
Yeah, way.
Go to draw.
Right.
Yep.
Hands maybe.
So once you get that graph, what I want you to do, okay, what I want you to do is draw it. Okay, so on your paper off to the right there, Just a rough sketch of what it looks like. Okay, so I have my curve. My mean is in the middle here. It was shaded from this point and then over. Okay, so that portion was shaded. Now if you look at your screen on your calculator with the graph, it says area equals. Okay, do you see that area equals part? Okay, it's 0.89. Okay, so I can say that area is equal to 0.896 or just 0.9. Okay, so that would be your probability. It's about 90%. Okay, my probability that you're finding people with a greater than 150 cholesterol is 0.9. Okay? The 3 comes from this right here. So your lowest bound will always be -3. Your highest one is 3. Okay, so if you're finding values that are greater than something, your lower bound will be whatever you find, and then your upper will have to be 3 because you're looking for the greater portion. Okay, other questions on how I did that one? All right, then we're going to do letter B the same way here, except letter B, we're looking for the probability of people between 145 and 165. So that means I need to find the z-score for both of those numbers. Okay, so I'm finding z. Using x is 145 for the first one. And I still have my mean is the same at 158.3 and standard deviation at 6.6. Okay, so that one is using 145. Okay, and you can just plug that into your calculator. 145 minus 158.3 is negative 13.3. Divide that by 6.6. That is negative 2.02. Okay, so that's going to be your lower bound. Now I want to find my upper bound because I'm looking for probability between the two. So I need to find the z-score with the 165 as well. So I have 165 for x. I still have 158.3 for the mean and 6.6 as the standard deviation. So we have 165 minus 158.3, 6.7. Divide that by 6.6. That's 1.02. Okay, so what this did was find my lower and my upper bound. So since negative 2.02 is less than 1.02, that's your lower. This one's your upper. And you're going to enter it in your calculator just like we did before. Keep the window the same, okay, so you can see it. So again, entering this in your calculator, you go to second, the distribution button. Go over to the right to draw, shade normal, second, distribution, go to the right, so it says shade normal, press enter, enter your lower bound, which is negative 2.02, and your upper bound, which is 1.02. Then press enter and it'll shade it for you.
Same thing.
Now it's shaded more. Well, less, but to the left more. So okay, then we draw. Okay, we have our mean in the middle. And this one is kind of like this. So it's between those 2 points there, and you just have the tails missing. Okay, in your picture. Then what does the area say for it underneath that curve? Okay, so that would be 0.824. That would be your probability of people between those two cholesterol levels. Okay, so that's shading it the easier way. Okay, where you don't actually have, it doesn't give you the graph and the area. Another method, the one I want you to use for calculating the area between two z values, is again second distribution, but instead of going to the right, you're going to click on the one that says normal CDF. Okay, so if I do that with the data I just had, okay, again, second distribution, okay, you want to go down to normal CDF on that first screen there, press enter, enter in your lower value of negative 2.02, and then your upper value of 1.02. And you get that area, which is 0.824, without even graphing it or anything. Okay, so we're going to do another example using that. Okay, so I'll do it again. Just doing another example without the graph. So the lifespan of a certain tread of tire are normally distributed with mu 31,066 miles and standard deviation of 1,644 miles. So we want to find the probability of each in letters A and B. So that means we need to find the z-score. Okay, so for letter A, we're finding between 30,000 and 32,000. So I need to find the z-score for both of those x values. So how would I set this one up?
30,000 minus 31,066 over 1,644.
Yes. Okay, so that's that first x value. You just enter that into your calculator. I got negative 0.65. And then I want to do the same thing with the second x value there. So now I have 32,000 minus 31,066 over 1,644. That is 0.57. Okay, so now I have my lower and upper bound. So we can take our calculator and find the area under the curve between the two. And we're not going to draw it out this time. So again, press second. The distribution button, which is right above the bars.
0.457.
Yeah. Go down to normal CDF. Press enter. Enter your lower bound, which is negative 0.65. And your upper bound, which is 0.57. Press enter, and it gives you that probability of 4 point, I'll just say 6.
Give me that homework already.
One more. Okay, last one. This one isn't a between one. So we just find the z-score again for that x value of 35,000. Nice, 3166 over 1,644. Okay, so I just plugged in 35,000 for that x value in my formula. That is equal to 2.39. Now I'm looking for values that are greater than 35,000. So what number will be my lower and what one will be my higher or my upper? If I'm looking for probability that it's greater than. This is my lower, and my upper would be what? 3. Good. So when I enter this into my calculator, again, second distribution down to normal CDF, we first enter the 2.39, and then we want 3 as our upper. Okay? So I get 0.007 as my probability. So that's like 0.7%. Okay, does that make sense?
How'd you get 3?
3 and -3 come from the standard normal. So your lower bound, the lowest it'll go is -3, the highest it'll go is +3. Brantley, what were you saying?
So the sign is no, it's just -3.
Yes. So if it was looking for X value less than 35,000, your lower bound then would be -3, and then your upper would be the Z value you found.